Right, so this is definitely an optional video, but I know sometimes, I know I like knowing where formulas come from, and I think some of you guys do as well. And so I wanted to just put together a brief video that talked about where the formula u1 times 1 minus r to the n all over 1 minus r. I wanted to make a brief video about where that thing comes from, right? So what we're going to do is we're going to sort of look at this as a left and a right side of thing. First, let's think about what Sn means. Right? Sn is supposed to mean the sum of the first n terms of a geometric series. Right? Well, let's actually write out the first n terms of a geometric series. It would be u1 for the first term. Then the next term would be u1 times r. The next would be u1 times r squared. The next would be u1 times r cubed, and so on. And what would the last term be? It would be u1 times r to some power. And if you're watching this video, you should be one for sort of doing things on your own. What power is that going to be raised up to? And like pause and really think about that for a minute. The correct answer should be that it's the n minus 1 power. And the reason it's the n minus 1 power is that we're supposed to have n terms, and our first term didn't have an r. The second term had r to the first. The third term had r squared. So the nth term is going to have n minus 1. Right? So now what I'm going to do is I'm going to factor that thing. I'm going to factor this by factoring out the u1. So it's going to be u1 times 1 plus r squared plus r cubed all the way up to r to the n minus 1. Okay? So that is effectively what the left side is. Right? The left side of this thing is that. And I'm telling you that for some reason that should be equal to the thing on the right. Okay? And so now I'm going to attack this from the other side of the problem. Let's now take a look at this. I'm going to leave the u1 out of it just to kind of to make things easier. I want us to think about what is 1 minus r to the n over 1 minus r. What happens when we divide 1 minus r to the n by 1 minus r? And I'm going to do this with sort of a really sneaky kind of division, right? Because understand, this basically means division, right? This effectively means 1 minus r to the n is equal to 1 minus r times something, right? And so I'm going to sort of do a sneaky division here. I'm going to say, well, if this is going to work, the first term here is going to have to be 1, because when I multiply 1 times 1, I'm going to have to get 1. Right? I would say then the next term has to be plus r. And the reason it has to be plus r is take a look at this. When I distribute the 1 here, I'm going to get 1, then I'm going to get minus r. So then I need to make this r so that when I distribute here, I'll get plus r, and those will cancel out. And then I'll get r times negative r, which is minus r squared. But that means my next one has to be plus r squared, so that when I distribute back, I'll get r squared times 1 is plus r squared. Oh, good, those will go away. And then I'll get r squared and negative r from minus r cubed. And you can probably see where this is going. I'm going to have to keep going plus r cubed, plus r to the fourth, plus all the way up, eventually to what? All the way up to r to the n minus 1. And the idea is, as I keep, distributing, like the r cubed to both of these, the r to the fourth to both of them, the r to the fifth to both of them, the r to the sixth to both of them, I'm going to keep canceling out the r's, then the r squareds, then the r cubes, then the r to the fourth, and so on. And in the end, all that's going to be left is the, and I'll use a different color for this, all that's going to be left is the 1 times 1, which gave me 1, and the r to the n minus 1 times r, which gives me this r to the n. Okay? So now why is this significant? This means that this fraction that we were working with is indeed equal to 1 plus r squared plus r cubed, all the way up to r to the n minus 1. I feel like this is probably a little bit disjointed, but on the other hand, if I take this thing and simply multiply it by u1, you'll see that the right side of this equation is equal to the left side of the equation. These things really are the same as one another. So where the formula effectively comes from is the idea that when you take 1 minus r to the n and like do long division on it, 1 minus r, you end up getting 1 plus r squared plus r cubed all the way on up, which is effectively the summation of a geometric series once you multiply by u minus 1. I hope that made sense. If you're willing to believe that, if you're willing to accept that formula, it's really easy to see where the infinite geometric series formula comes from. And I might as well throw that one in for free, since we're all here. If you're here this long, I suspect you're interested in seeing this. And if not, my feelings won't be hurt if you run away from the video. This is the summation for a finite geometric series. If you've got 5 terms, 10 terms, 17 terms. If we have an infinite series, it's u1 over 1 minus r. But remember, this formula only works if r is between -1 and 1. And so the question is, where does this formula come from? Well, the reality is it's simply this formula up above. It's just the formula when you take the limit as n approaches infinity. Because think about it. As n approaches infinity, what happens to r to the n? Well, you might be thinking, oh, well, if the power is really big, then this number gets really huge. Well, it's true if r is a big number. But if r is between -1 and 1, what happens when you take a small decimal between -1 and 1 and raise it to a huge power? It turns smaller and smaller and smaller and smaller, eventually turning into 0. So what you end up with is just the u1 times 1 over 1 minus r. And so you can see that the infinite geometric series formula actually comes from the finite formula. It's just that when you take the limit and the ratio is less than 1, this part goes away and you're just left with the rest of it. So it's good to know where this stuff comes from. I hope you enjoyed that. See you in class.